To understand how X rays are produced, we must be able to understand how X radiation interacts with atoms. So that means understanding what an atom is and what the basic parts of an atomic structure is. So, to start with, everything in the world is composed of matter and energy. And to define matter, it's just simply anything that occupies space and has mass. So, everything from the chair you're sitting on to the headphones you might be using to the computer, phone, iPad device that you may be listening to this on, it's all matter. And the basic building block of all matter is an atom. And all atoms are basically made the same way. All matter is made of atoms, and all atoms have an inner core. That inner core is known as the nucleus, and that nucleus has a positive electric charge. On the outside of the nucleus, there are tiny little pieces that orbit around this nucleus, and they orbit around on these little rings called shells. And those little particles are called electrons, and those electrons have a negative charge. So back to the nucleus. The nucleus is composed of positively charged protons and neutrons that have no charge. So think of this little tiny shell or this little tiny ball, and that ball is your nucleus. And inside, if you could break open that ball, inside of that ball, there would be little tiny particles known as protons and neutrons. Protons have a positive charge. Think pro is a positive thing. So protons have a positive charge. Neutrons are neutral, they have no charge. And then those electrons that orbit outside of that little ball have a negative charge. And each atom is going to have a certain number of electrons, a certain number of protons. And in a neutral atom, the number of electrons will equal the number of protons in the nucleus. So on the outside rings or the orbits, they're also known as shells, you have the electrons. So if you have 7 electrons on the outside of the ball, you're going to have 7 protons on the inside of the ball, and that would be a neutral atom. So this is a representation of an oxygen atom. So you can see inside the nucleus, you can see little plus signs and little minus signs. Little plus signs, and then the little, better not call it a minus sign. Let me go back. Let me start this slide over again. Minus might make them think that they're negative. So this is a representation of an oxygen atom. So you can see inside the nucleus, so this is the nucleus right here. Inside the nucleus, there are these little representations of the particles known as protons. Protons are positive, so all those little plus signs are positive protons. Then, on each shell or orbit, you can see here this is labeled the K orbit, this is labeled the L orbit, there are negative signs. These are your electrons. And it would continue out. We could have another ring here. Use my drawing. This would be the M shell. And then another one here. N. O. P. I drawing is terrible and I apologize. And this last ring here would be Q. And that's going to be the maximum number of shells. You will only have 7 shells in an atom. So the shells are going to be labeled K through Q. And K shell is the closest, and it is going to have the highest energy level. So it is going to be bound the tightest to that nucleus. So that brings us to ionization. And ionization is the harmful effect of X-rays that result in disruption of cellular structure and causes permanent damage to living cells and tissue. Basically, what ionization is, it's when you have one of those atoms and that atom gains or loses an electron. That's the process of ionization. So during ionization, electrons are removed from the electrically stable atom by collision with photons. So X-rays are photons, they're little bundles of energy, and that little bundle of energy will come in contact with an electron and it knocks the electron off of that shell. The atom will lose the electron, it becomes a positive ion, and the negative electron becomes a negative ion. So you've got two unstable things kind of swirling around out there in space, if you want to think of it that way, and they interact with and damage other atoms, the tissues, and the chemicals. So you basically can have an electron kind of floating around out there, and if it attaches itself to another atom, it can change the structure of that atom. And that is what essentially can change the composition or change the structure or to cause damage to our body. We have a couple different types of radiation. And knowing and understanding these types of radiation will also help you understand how those atoms might react or how those atoms might respond to interaction with radiation. So, the first type of radiation is called primary radiation. This is the radiation that is produced at the anode and exits. Okay, hang on, let me go back and fix that. The first type of radiation is known as primary radiation. This is the type that is produced at the anode and exits the tube head. So inside that glass vacuum, inside the tube head, where you have the tungsten target, I'm ahead of myself because I don't know at this point if they've got to the tungsten target because I'm not exactly sure what order you're putting everything. I assume this would come first. So let me go back here and start this slide over again. Sometimes take 3 is the best. Practice makes perfect, right? The first type of radiation is known as primary radiation. This is produced inside the tube head and exits through the tube head. It's also known as the primary beam or the useful beam. The second type is called secondary radiation. This is when that primary beam interacts with matter. So it exits the tube head and it comes in contact with your patient's tissue. That is where it becomes secondary radiation after it has interacted with matter. It is less penetrating than the primary beam. It's traveled the length of that tube head and it's lost some of its energy. The third type is scatter radiation. This is another form of secondary radiation because it does come into contact with matter, but this is when it has been deflected from its path. So it comes into contact with matter and it kind of think of it as it zings off in another direction. So If you throw a ball and the ball hits the wall, you don't necessarily know what direction that ball is going to go, where it's going to bounce to. Same way with the scatter radiation. So it's secondary radiation, but it's given the name of scatter radiation because we don't know where it goes. It's totally deflected from its path. It can go in any direction, and it is harmful to both the patient and the operator. We can't see it. We don't know where it's at. We don't know what direction it went. So it is very harmful to both patient and operator. And at this point, it's where we start to get our interactions of radiation. So, what exactly does happen at that point? There are a couple of different paths that the radiation can take. First, no interaction. The x ray is going to pass through the patient, and there's no interaction at all. And if there's no interaction, it's going to leave no changes. So, this atom will not have changed at all. The other type we can have, it is completely absorbed by the patient. Ionization may occur because an electron is ejected. That electron that was ejected, it's going to have that negative charge, and we call it a photoelectron at this point. And it doesn't have very much energy, so it can very easily be absorbed by other atoms. So once that X-ray comes into contact and it begins to be absorbed, that electron is ejected, photoelectron becomes a photoelectron, and that photoelectron is a negative charge, but easily absorbed because it is weak. It has little energy. The third type of interaction is when it is deflected from its path. So this is a form of scatter radiation. This type is known as Compton scatter, and there is ionization. The third type of interaction is when that is deflected from the path. The third type of interaction with X radiation is when it's deflected from the path. So this is a form of scatter radiation. And it is known specifically as Compton scatter. And with this type, ionization does occur. So that electron is ejected. It goes on a bunch of different paths, or it has a bunch of different potential paths to travel, and it's going to lose energy as it travels along that path. It is now weaker, and it will continue to interact with other atoms until all the energy is gone. And the fourth type of interaction is where it is also deflected from its path, and this is again scatter radiation. But this is called coherent scatter. There's no ionization and there's no loss of energy. That electron or that photon is scattered still in different directions, but there is again no loss of energy, there's no ionization. Everything remains unmodified, and that is the 4 interactions of radiation. So to review, what type of electrical charge does an electron carry? Is it A positive, B negative, C there's no charge, or D could be positive or negative? And the correct answer is B negative. An electron is a negative charge. 2. All matter is made of A. Molecules, B. Cells, C. Atoms, D. Energy. The correct answer is C. Atoms. The radiation that exits the tube head and is the penetrating beam is known as A. Primary radiation, B. Secondary radiation, C. Scatter radiation, or D. X radiation. And the correct answer is A. Primary radiation. And the last question, scatter radiation, A, is also referred to as the primary beam. B is created when radiation interacts with matter. C is radiation that has been deflected from its path. Or D is not harmful. And the correct answer, C, radiation that has been deflected from its path.